We're going to take a look at the learning target. I can factor a quadratic trinomial where a is equal to 1 into two binomials. So what you need to know, when we want to factor a quadratic into two binomials, we can follow a set of steps or a procedure. The first step in this procedure is to factor out the greatest common factor. So if you have a greatest common factor, you want to factor it out of the problem. So in this example, we have 2x squared minus 14x plus 20. If I look at my coefficient parts there, I can see that they all have a multiple of 2 that I can take out or divide out of each term. So since the GCF is 2, my new factored expression would look like 2 all times the quantity of x squared minus 7x plus 10. Now that we've done that, we're going to go ahead and add two sets of parentheses because we want to factor that entire trinomial into two binomials. So it's going to look something like this. I'm going to have my GCF out front, and then I've got my parentheses open for my two binomials. The third step is to add an x, or whatever your variable is, into those first part. So the first term in my first binomial and my first term in my second binomial, I put my variable. Now we want to create a multiply or add table. So the whole point behind factoring is to find what values multiply to give you the last term, so in this case 10, but they add to give you the middle term, or the negative 7. So we want to multiply to the last term of 10 and add to give to the middle term of negative 7. So if I start looking at some factors, factors of 10 would be 10 and 1. And if I add 10 and 1 together, I get 11. That doesn't equal 7 or negative 7, so that's not going to be what I use. So then I go down the list. Okay, I know that I can also have factors of 5 and 2. Well, 5 plus 2 is 7, but I need it to equal negative 7. So what about if we were to multiply negative 5 times negative 2? Those are still factors of 10. And when I multiply them together, I get a positive. But when I add those two negatives together, I get negative 7. So that's what I'm going to use here. Once I have my factors, we go ahead and we put those into my empty spots of my binomial. So I've got my 2, my GCF out front, and then x minus 5 times x minus 2. You can check your work by using FOIL. You can go ahead and distribute that first term of the first binomial to both of those, and then the second term to both of those. You'll get this here. And then when I go ahead and multiply that, oh, I haven't done that yet. I'm going to add my like terms first. So negative 2x minus 5x is going to be that negative 7x. Then we can go ahead and multiply that 2 all the way through. And we see here that we are ending with where we started. So we did indeed factor this correctly. Look at this a couple more times. Here is my beginning problem, x squared minus 9x plus 20. We want to factor out the GCF. In this case, I don't have any coefficients in all three terms, and I don't have a variable in all three terms, so there is no GCF. I'm going to go ahead and start with my two sets of parentheses, and I'm going to add my variable of x into those first spots of each binomial. Now I want to create my multiply add table. So in this case, I want to see what multiplies to give me that last term of positive 20, but it's going to add to give me this negative 9. So I'm going to run through a list of my factors. So when I think of 20, I think of 2 and 10. 2 times 10 is 20, but when I add those together, I get 12. That doesn't equal 9, so I can't use those factors. Another set, if I did negatives, negative 2 times negative 10 would still give me positive 20, but when I add those, I get negative 12. Not what I need. I need it to add to negative 9. So 4 and 5, 4 times 5 gives me 20, and 4 plus 5 gives me positive 9. I need it to equal negative 9. So instead I'm going to use negative 4 and negative 5, because when I multiply two negatives, I still get positive 20, but when I add them together, I get negative 9. So I'm going to go ahead and fill in those two factors. Here's my factors. I just filled those in to my binomials, and then we can go ahead and check our work. After you've distributed all of this through, we end up with x squared minus 5x, and then negative 4x plus 20. If I simplify that, by combining my like terms, I get x squared minus 9x plus 20, which is where we started. So my factors here of x minus 4 and x minus 5 were correct. Great time for you to pause and try this one on your own and then come back and check your answer in a second. Here I'm starting with m squared plus 10m plus 16. We want to see if we have a GCF. I don't have one here. There aren't any coefficients in all three terms. I don't have a variable in all three terms, so I can't factor anything out. I'm going to go ahead and open up my two sets of parentheses for my binomials. And I'm going to add my variable to both the front spots. In this case, I'm using m instead of x. And now we go ahead and we make our table. So this time I want to find two numbers that multiply to give me 16 and add to give me 10. So when I think of 16, I think of 2 and 8. 2 plus 8 is 10. 2 times 8 is 16. Cha-ching! We got it on the first try. I just go in and I fill in those two number parts into my binomials, so m plus 2 and then m plus 8. If you want to make sure that you got this correct, you can go ahead and check using FOIL. After you've multiplied everything through, we end up with m squared plus 8m plus 2m plus 16. When I simplify by combining my like terms, I end up with m squared plus 10m plus 16, which is exactly where we started. This answer here, m plus 2 all times m plus 8, is the correct factored trinomial. If you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.